Afternoon, good evening. My name is Ian Coates, and I will be your facilitator for Physics 1006. Little bit about me. I've been at Georgian now. This is my fourth year. I'm a local yokel, originally from Barrie, and I was gone traveling there for about 20 years. I was over in Eastern Asia, Africa, Middle East, just traveling around teaching. And nice to be back home, and I hope you guys are all well and safe here. I know, like, if you hear kids screaming in the background, my two kids, I got a 7 and 4-year-old, they're raising heck downstairs, and I hope you guys are coping well. The best thing I can do or say, get outside and get some fresh air, and don't ever lose track of getting outside. Some vitamin D tablets. The sun is not shining there today. Exercise, mental health, physical health, they're both tied together. So anyways, I hope all is well there with you guys. Welcome to the lecture 1 there for Physics 1006. I'm going to break this up into 2 parts. It's more of an introduction to physics there for the first half. I'll introduce the course and what's entailed and all that. And then the second half there, we'll get into vectors and a little bit of trigonometry. But before I say anything, I've already received emails there. And by the way, I love emails. I'm not one of those teachers that shies away from questions and hates students bothering me, no. Even when we had in-person classes, ask as many bloody questions as you can, because that's the only way you're going to learn. All right? And like, I'm your facilitator, but you guys are going to be your own teachers, because ultimately you guys have got to learn this stuff. And this course here, the chemistry as well, you guys just finished Chem 1 or 1008. I'm also teaching a Chem 1009 there this semester. I don't know if any of you guys will be in my class or not. I'll check that out there. That class is on Thursday. But I don't want you guys to freak out about physics. Physics has this negative connotation, as does math. And some people have math phobias and all this kind of stuff. And I don't want you guys to freak out. This course is designed for people who have never taken a physics course before. Okay? And the point of this is so you don't become physics masters at the end of it all. It's the whole thing about this course is to teach you, or to show you how you interact with the world around you. And, I've got my nurses, I've got my vet techs, I've got my paramedics, I've got my firefighters. I'm just trying to think, did I forget anything else? But PSWs, these kinds of things. You guys are going to go out into the world. The world is governed by mathematics. And that's what this course is going to show you. And we're not going to go into the crazy stuff. It's every week there's going to be a new formula set, and I will update this week upon week, so that therefore now when you have your test, you'll have your formulas ready to go. And if you read my announcements there, please, 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 pretty please, with sugar on top, go and get a scientific calculator. Okay? You can get them for $10 at Staples, if you can get into Staples there these days. But you can use your calculator on your phone. I've seen it done. I've seen people make mistakes on it. And how these tests, quizzes, these kinds of things are going to go, they're mainly going to be multiple choice. There will be some short written answers here and there, and that. But you see, written answers, there's the ability that's bestowed upon me that I can give half marks. But a multiple choice test, it's either right or wrong. So these calculations that you're going to be doing, they got to be right. So please go out and get a scientific calculator. And the most important button on there, like this week there, we're going to use sine, cosine, and tangent. But it's the EXP button. And that's for scientific notations. Because in biology, chemistry, physics, we either use huge numbers, like the mass of the Earth in kilograms, or the number of atoms in a cupcake, or we'll use very, very, very small numbers, like the mass of an electron, or mass of a proton, or something like this. So, without further ado, today's lecture is going to be a little longer than I would anticipate because I got to introduce the course and all that. You guys can see the course syllabus. This is what you want to know. This is what you want to have somewhere. Okay. And the other document there on Blackboard is the course outline. That's from Georgian College. This is what you want to know. There's my contact information right there. Again, it's all on Blackboard. Email. If you have any issues at all, email me. If you're having trouble at home and you're falling behind or something happened or somebody's sick or, you know what I mean, just keep me in the loop. Okay? If I don't know what's happening beforehand, then I can't make adjustments the morning of. So just keep me in the loop and we'll get her done. The lecture, I'll post a lecture either live or I'll upload a recorded one. But either case, I'll record my lecture and post it onto YouTube. Okay? Or some other, I'll show you guys there the link. So it's not mandatory that you show up Tuesday at 12 o'clock. There you go. No. We have people working. We have people who are sick. It's a pandemic. So as long as you can hit the lecture in a reasonable amount of time, that'll give you a week or so to work on the practice questions and this and that. Because this course, as with a math course, you've got to keep on it. If you miss a week, you fall behind. Now you've got double to learn. That's this course. Please do not neglect it. And for your chemistry, 1009, again, do not neglect it because the first half of that course, weeks 1 to 7, it's kind of a math course with a chemistry aftertaste. Okay? So, and even if I'm not your teacher there for a particular course, I've taught all the science courses there, bio, chem, physics, both maths. I think you guys are doing the statistics there this semester. If you're having any issues, just email me. Okay? The lab tutorial, all labs are going to be virtual. But starting week 3, I will open up a little tutorial just to hear concerns, to hear questions if you're having any issues. So that'll be starting, February 1st, every Monday, 10 a.m. to 11. But again, this is peanuts comparing to just emailing me. And we'll set up WebEx, just me and you, or whatever, a group of you, or however it's going to work. So keep me in the loop. Blah, blah, blah. There's your textbook. Again, 3-hour virtual lecture. But you don't have to attend it that particular time. This is what you want to know. There will be 2 assignments worth 7.5% each. And I'll show you there down here. Okay, there's the actual schedule, but we'll go back up here now. So the assignments will be posted weeks 4 and 10. You'll have 2 weeks to hand them in. Okay, we'll get into handing in procedures. There are 5 labs. They don't start till week 3. You'll see there that I'll post the first one there week 3. And you have a week to hand them in. So you'll hand it in week 3, or I'll post it week 3. You'll hand it in week 4. And I'll post the next one week 5. You'll hand it in 6. So that's how it'll go. We have time for that, so don't worry about partners, this and that. I'll update you guys all about that there when labs are coming. Okay. There are 4 quizzes. Okay. And they will happen on weeks 3, 6, 9, and 12. And how they'll just be a multiple choice test of some kind. And you'll have like a week to do it. So how it'll work is lectures on Tuesday. I think they're 12 to 3. So I'll open this quiz up at 3 o'clock. And you'll have a week to do it, or you'll have until the next lecture to do it. Okay? And they're worth 3% each. Now, this is the crux of the whole course. Like, how we've all been used to things is you have a midterm exam, which is kind of like a final. You'll have a final exam there at the end of the course, and that's how it goes. Well, those are pretty stressful. And I've seen people have bad nights. And, great students have bad nights, and then they flunk the exam. Exams are a lot of pressure. So what we've done is we've spread the final exams out. So basically you have 4 final exams. All right? That are worth 12% each. And we'll have 3 weeks of class, and then we'll have a test. And that'll be a final test. And we will not go back to that information. That information is finished. We're going to move on to Unit 2. And then I think we have 3 weeks of lecture there or so. And then we'll have a final test. And then that's how it'll break down. So every three or 4 weeks, we'll have a test. And then we move on to something completely new. All right. We'll get more into that, though, there later. What we got here, Blackboard handing in procedures. Last semester was a bit of a nightmare. I was in the biotech department, and the labs, some people, they'd upload a Word document. This person would upload a PDF document. We've got Mac documents. We've got encrypted documents and password protected documents. And what happens is, student will upload a document. I can't open it on Blackboard, so then I have to email them, all right, and get them to send me another copy. Blackboard, there's only space for 1 copy, so then they have to email it to me. So now I have tests, labs, assignments all in my email. And just to make things easy, all documents to be uploaded have to be a PDF. Okay, and if anyone's using a Mac or any type where their documents, there's a password protection of any kind, it has to be removed. Okay, because it was when you've got 250 assignments on Blackboard and another 375 in your email from all different students from all different classes, and that's why I just want to keep these documents on Blackboard. Okay, I understand things can happen. I'm pretty flexible, but please, that's my only gimme. All right, gimme. Only PDF files to be uploaded. Again, things are late. You get a mark of 0. Okay, but I do understand that things happen and life sometimes gets in the way. And family, you can't pick your family. You're stuck with them. Trust me, I know. So you guys all made the decision to come back to school for a reason, to better yourselves, to better your family, and it makes no sense to finish a degree and better yourself when your family's in chaos or turmoil or something. So if there are issues going on with family, let me know. I can make accommodation. Don't give it to me the day of, all right? But I will do anything I can to get you guys through. Just be upfront with me and give me time to roll with the punches, all right? Yeah, assignment 7.5%. The labs we've talked about. You'll have a week to do them. Online quizzes. There you go. It's not, and the test, there are 4. Yeah. Office hours, I don't really have any. I'm just by my computer all the time. So just email me and I'm pretty good to get back. This is what you want to print off, maybe have on the wall. Okay. Week 1, 2, 3, 4, 5, 6, 7. Reading week is here. Okay. And then we got 8, 9, 10, 11, 12, 13. All right. So let's just go through it quickly because I don't want to be here for 8 hours. I'm sure you don't either. The textbook, it's a good read. If you have it, read it. If you don't have it, then I guess it's really not necessary. You should be able to cover everything from the lectures there that from my PowerPoints and videos and the questions there that I post on Blackboard. You should be able to get through it. So it's always good there to have a backup with a textbook. Anyway, week 1, vectors. Okay? Week 2, study of motion. It's where we're going to get into Isaac Newton, Sir Isaac Newton. And we get into the differences there between distance, velocity, acceleration, centrifugal acceleration. Week 3 will be your first quiz. And it covers, so we'll do week 1, we'll do week 2, we'll do week 3. And then at the end of week 3, I will open the quiz. And it will cover all of this in preparation for this. Okay, so the following week, week 4, I will post a new PowerPoint, but I will also post the test. Okay, online, you'll do the test. You also have your lecture here, but this lecture here is not for this test. Okay, the test is for weeks 1 to 3. All right, here we've got weeks 4, which is gravity and projectile motion. Week 5, we've got energy and conservation laws, momentum. Week 6, we have another quiz and energy continued. And then week 7, you'll have your test on weeks 4 to 6, and I will open up another lecture. Okay, so that's how it goes. And the same continues on. We've got temperature, heat, waves and sound. You'll have another test, and then your final test there will be electricity, electromagnetism, nuclear physics, and a little bit of optics. All right, so the last test will be on 3 units there. So you guys are going to do just fine. But don't let this stuff slide. This stuff is mathematics. Get yourself a good calculator. Let your calculator be the donkey. Let your calculator carry you. All right? And get that good calculator, and you guys should just be fine. Okay? And due to extenuating circumstances because of COVID, we may have to modify things. I think we're pretty good because this course is 100% virtual anyway. All right? And that's that. You guys can have a look at that. Let's get started, shall we? Welcome to physics. What is physics? Great show. I actually think they hired 1 or 2 physics PhDs to sit on the show and help them write, because their stuff is pretty good as far as scientifically sound goes. And let's keep going. This man here, Stephen Hawking's, actually a great movie. Story of his life. God, was that Russell Crowe? I forget who it was now, but you can go find the movie. One of the most profound minds of our time, and just passed away recently. All right. The quirks, quarks, quacks of physics. Here we go. So what exactly is physics? Physics is the study of what will happen next. And I don't know if you guys have ever played this board game or not. I actually just bought it there for my kids there for Christmas, and it's quite tedious to put together, actually. It took me about 4 hours. Still didn't work. Still sitting in the box. Physics is the study of what will happen next. We're trying to predict. We're trying to make the universe a little bit more reliable. And ultimately, scientists like to deal with equations. And we'd like to find out an ultimate equation there for the entire universe. That's what we're kind of working on. Will we get there? Who knows? Physics it is a basic science. All right, this is one of the fundamentals. And if you look at physics governs everything. Like if you look at biology in our body, you know what I mean? We eat food for energy, right? And it's exactly the same thing. I don't know if you, when you throw a log on the fire keeps going, right? Because it's burning the log. And what do you think you're doing with your food when you eat it? It's exactly the same process. Your body is burning that food just at a very low temperature. And it's extracting the energy from it, which therefore now you can utilize this energy to perform functions and tasks and exercise and learn about physics, right? So physics is a basic science, and we'll look at things like force, motion, energy, heat, light, sound. These things happen, and they happen the same way every time. So there is a fundamental basic principle behind all of these different concepts, which we'll kind of touch on. Physics provides the foundation for all of our sciences. A basic understanding of physics provides a basic understanding of science. Thank you for that. Here we've got states of matter. Water can be a gas, a steam, solid, ice, and liquid, like water, right? Like liquid water, swimming water. But there's also a fourth state of matter called plasma. This exists in the middle of stars. Okay? It's when we get into where we're going to go, we'll get into what plasma is. It's just a primordial mixed soup of protons, electrons, and neutrons, just in a massive soup. But we'll get there. Physics covers quarks, neutrinos, atoms to the very large planets, stars, and galaxies. And being able, like, there's a what's his name there? Tesla. They want to send people to Mars. Well, the universe tends to work in a very uniform way. So now, how are we going to send a spaceship there to Mars? How do we know where Mars is going to be 8 months from now? Well, this is the whole thing, is we can predict where things will be. What else we got? Here. You'll probably see the same picture in my chemistry slide if you're in my chemistry class. But here we've got molecules. These are all atoms that are bonded together. And you guys learned about that there last semester in chemistry, that ionic bonds and covalent bonds. There's actually a third one called metallic bonds. And these are atoms that come together. They form these specific structures, and these structures, based on the arrangement of atoms, perform certain functions. Okay? Here we've got the other end of the scale. Here we're looking at this one here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 or so atoms. Here we've got hundreds of gazillions of them. Let's have a look, shall we? Oh yeah, that's a good one. Da, da. If you've already seen this or you don't want to see it, you can just fast forward. I enjoy it. Da, da. Awesome. Hopefully you're still there. I haven't scared you away. Science. The whole idea of science is basically we're not interested in anyone's opinion. Science is the body of knowledge that describes what happens in our physical world and why. Science is an ongoing human activity. I really like this. Represents a collective effort to finding knowledge, past, present, and future. Science is the gathering of the knowledge about our physical world and then organizing it into testable laws and theories. Okay? The whole point of science is that it needs to be reproducible. So if I do an experiment here, in order for that to be sound, logical science, somebody should be able to do the exact same experiment in Seoul, South Korea, or Moscow, Russia, or Sao Paulo, Brazil. Okay? In the beginning, the whole idea of atoms and that there was something else has been known for a long, long time, a couple thousand years. I think the Greeks were on it. The idea that an atom, that there were smaller bits to what I could see. Okay? There were patterns, irregularities that people started to notice. Things happen on a regular basis. Rainy season, dry season, winter, these kinds of things. Star patterns. So they started to record these patterns, and once something happens on a regular basis, now you can study it. This is quite funny.
The Earth. You may know it as that blue thing Bruce Willis is always trying to save. Or from its famous collaboration with wind and fire. Or just simply as that place where George Clooney lives. Anyway, the Earth had some genuinely bad news this week.
A White House report that says global warming threatens every part of the U.S.
This isn't something in the distant future. Climate change is already affecting us now.
Now. Smart move, Obama. That is a key shift in how to talk about climate change, because we've all proven that we cannot be trusted with the future tense. We've been repeatedly asked, don't you want to leave a better Earth for your grandchildren? And we've all collectively responded, Incredibly, this latest damning scientific report may still face an uphill climb with some of us.
There's that Gallup poll that came out last month, which found 1 in 4 Americans is skeptical of all the effects of climate change and thinks this issue's been exaggerated.
That doesn't matter. You don't need people's opinions on a fact. You might as well have a poll asking which number is bigger, 15 or 5. Or do owls exist? Or are there hats? The debate on climate change should not be whether or not it exists. It's what we should do about it. There is a mountain of research on this topic. Global temperatures are rising. Heat waves are becoming more common. Sea surface temperatures are also rising. Glaciers are melting. And, of course, no climate report is complete without the obligatory photo of a polar bear balancing on a piece of ice. The only accurate way to report that 1 out of 4 Americans are skeptical of global warming is to say a poll finds that 1 out of 4 Americans are wrong about something. Because a survey of thousands of scientific papers that took a position on climate change found that 97% endorsed the position that humans are causing global warming. And I think I know why people still think this issue is open to debate, because on TV it is. And it's always 1 person for, 1 person against. And it's usually the same person for.
Bill Nye and Marsha Blackburn, welcome both of you to Meet the Press.
Bill Nye joins us now, along with climate change skeptic Mark Morano.
Joining me now to go head-to-head, Bill Nye, science educator and CEO of the Planetary Society.
In the crossfire, Bill Nye, the science guy.
Bill Nye, the science guy who believes in man-made global warming. Yeah, that's right. More often than not, it's Bill Nye, the science guy, versus some dude. And when you look at the screen, it's 50-50, which is inherently misleading. If there has to be a debate about the reality of climate change, and there doesn't, then there is only one mathematically fair way to do it.
Last Week Tonight presents a statistically representative climate change debate.
Good evening. Joining me tonight, a climate change denier and, naturally, Bill Nye Science Guy.
John?
Yeah.
Humans are causing climate change? No question.
Wait. Before we begin, in the interest of mathematical balance, I'm going to bring out two people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little unwieldy, but this is the only way we can actually have a representative discussion. So, yeah, please file in. Again, this is going to make the debate difficult. We shouldn't really be having it in the first place. But, so, representationally, climate skeptic, please make a case against climate change.
Well, I just don't think all the science is in yet. It's settled.
Okay, and what is the overwhelming view of the entire scientific community?
Well,
Okay. Any response to that? Any response? I can't hear you over the weight of scientific evidence. This whole debate should not have happened.
You get the point. When it comes to science, there is no opinion. Nobody cares what anybody thinks. There's no emotion. It's just fact. And so we'll get into part 2 here with measurements, methods, and mayhem. Scientific measurement. How much we know about something is directly related to how well we can measure it. 19th century there, this Lord Kelvin there, he hypothesized when you can measure something and express it in numbers, you know something about it. If you cannot, then your knowledge is meager and unsatisfying. So that's why we say 2 + 2 is equal to 4, because you cannot dispute it. It is what it is. 2 apples plus 2 more apples gives you 4. Scientific measurement is not a new concept. There we've got the 3rd century there, scientists were doing all this, and when we get into the chemistry there, I'll talk to you a little bit about alchemy, and that was the start of chemistry and organic chemistry. The Babylonians were already on to the idea of stars, planets, and the moon, and it kind of boggles my mind that up until the 15th century, the Earth was still considered by its scholars to be flat. Shocking, eh? Scientific measurement. The SI unit, Systems International, for measurement there is the meter. And there's actually a scientific definition for what a meter is. A meter isn't just a meter. It's defined as the length of the path traveled by light in a vacuum during a time interval of this number here. All right. And just to try this out here, 1 divided by 299. I'm just doing this on my calculator right here. 2, 2, 4, 5, 8 equals. Can I do this here? 3.33 times 10 to the -9. So, alright, just trying to get this up. For some reason it's not allowing me. Okay, I'll just do this one here. Superscript. So that's supposed to be -9. That's, there we go. Now it's allowing me. And superscript. So these two numbers here are actually the same thing. And this number here, 3.33 times 10 to the -9, is, let's have a look here. There we go. It's equal to 0.0006333. So I think that that's where we are at. No, I need 8. So I have 6. There we go. I think that's right. We should have 8 zeros there before the decimal. So this is the whole idea of scientific notations. You see, these are very, very small numbers, okay? And wherever your decimal place is, you just, is this number greater than 1 or less than 1? If it's less than 1, this number here will be negative. If it's greater than 1, then this number, the exponent here, will be positive. But in this case here, 3.33 times 10 to the negative 9. So if you want to convert that, wherever your decimal is, 1, 2, 3, 4, 5, 6, 7, 8, 9. So your decimal goes there. So 3.33 times 10 to the negative 9. If this is your first time seeing these kind of numbers, don't worry. I have a practice sheet there that I'll throw out at you guys, and you guys will have it in 2 minutes. So don't worry. This is scientific notation, and we'll get there. Another unit of measure is the second. Okay, you guys can read all that. I don't want to drag this out for too long. Another unit of measure is the kg. Okay, kilogram. So we had the meter, the second, the kg. Now, you guys can read all this here, but I like this one right here. When you guys get into your programs and you guys start doing experiments, and I hope that, you know, I still have students that contact me. I have students that are at Western, U of T. They've graduated from here. I say this pre-health program works. You get your pre-health, you get into your nursing program, your paramedics, your firefighters, whatever. And then, you know what? Go and work. Come back to school. Never done learning. Go and get a master's degree. Change the world in different ways, as many ways as you can. So when applying the scientific method to scientific thought or practice, if we're going to investigate something, first of all, what are you investigating? State the problem. Okay? What is the problem? What are you investigating? Or what are you going to investigate? And this is how research happens. Big pharma, biotech companies and all this. State the problem, but before you invest a penny into any research, you got to find out if someone else has done it. Because maybe what you want to investigate has already been done by some guy in Florence, Italy. And he wrote a paper, he did his master's on it. So therefore you just saved yourself $500,000 in grant money. All right? So state the problem, gather the information. If there isn't any information on it, let's move forward. Form a hypothesis. Now what is a hypothesis? A hypothesis is just a guess. Let's say I'm holding this glass of ginger ale. And I hold it out. And I say, all right, I want to find out what will happen if I drop this glass. If I just let go of it. Is it going to go up or is it going to go down? Well, you know what? I think that this glass is going to go up when I let it go. Is that a bad hypothesis? Absolutely not. A hypothesis, there's no such thing as a good one or a bad one. There is only the truth. So, okay, so I think this glass is going to go up when I drop it. Okay, so I'm now going to test my hypothesis. I'm holding my glass of ginger ale out. Boy, I just came up with that. It's pretty silly, eh? But, okay, point is, I'm going to test it, and I let go of my glass of ginger ale. Darn it. Fell down, and I broke my glass, and my ginger ale's all over my shoe. What's going on here? Analyze the data. How fast did it fall? How many pieces did it break into? What exactly? We know we want to gather some numbers here. And then you draw a conclusion. Well, I thought that this thing was going to go up, but it went down. But it was on its own. There has to be some force or something acting on this glass that's pushing it down onto my beautiful linoleum floors. If my hypothesis is not supported, go back to the drawing board. It's okay. It's all right. That's science. You didn't make any mistakes. And you see, even if you make, quote unquote, a wrong hypothesis, it still leads you in the right direction because you got to go back, right? If your hypothesis is supported, now let's do this sucker a couple times and see if it is true always. And here's the same example. Observation, hypothesis, experiment, outcome. You guys can have a look at that. Same thing. These are some good little definitions that you just might see again. Scientific fact, simple basic observation that has been shown to be true. Hypothesis, educated guess about something that may or may not happen. Scientific theory and scientific law. Theory, a law is the ultimate. There are actually very few scientific laws because how do we stop testing for them? In different realities, different, like science for atoms, how atoms behave is very different than how planets behave. And so like Einstein's theory of relativity, y'all have heard of that one. E is equal to mc squared. Einstein's theory. They're still testing it every single day. Does it work? Do we rely on this thing to get spaceships to Mars? Absolutely. It's still a theory. When will it become a law? Who knows? Okay. Have a look at those. Read those. You might see those again. Here we go. Scientific theory. Einstein's theory of relativity. Darwin's theory of evolution. Scientific law. Newton's law of motion. Laws of thermodynamics, heat exchange. These are all held in high esteem. Okay. Scientific contradictions. Aristotle hypothesized that an object fell at a speed that was directly proportional to its weight. Therefore, an object that weighed twice as much would fall twice as fast. So, if you're standing on top of the edge of a castle, or actually, here, I got this one right here. Here we got the Leaning Tower of Pisa, okay, which is actually one of your review questions there. But here we've got a bowling ball and a tennis ball. You could use a bowling ball and a banana. And you see here, you drop them at the same time, you expect the heavier object to fall faster, right? It ain't so. They both fall at the same time. So the mass, the weight of an object doesn't impact its speed back towards Earth. So you go back here, this hypothesis was thought to be correct, but it ain't, because Galileo did this experiment and showed that its gravity has nothing to do with your mass or your weight. Again, we don't want your opinion. Scientists must distinguish between what they see and what they would like to see. Sure, scientists, you know, their jobs depend on them getting results so that the company can mass produce this and make big bucks. But scientists have to follow a protocol. And whenever they come up with they do an experiment that seems to be working, they'll do it again, do it again, do it again. They'll write a paper on it. It will be peer reviewed by other people in the same field to make sure that it's okay. All right? Can't fudge facts. All hypotheses must be testable, reproducible, and susceptible to being proven wrong. There is no right answers or wrong answers. There is only testable, reproducible, and the ability there to be tested wrong. Be careful of these guys here, hypothesis and speculation. Okay, speculation is what you think. Hypothesis there is what you think is going to happen. Okay, this one here involves emotion. This one here is scientific. Intelligent life exists on other planets somewhere in the universe. Is that a hypothesis or a speculation? Intelligent life exists on other planets somewhere in the universe. Well, you're kind of stating something. Can you test this? Not at the current moment, but what do you say? Speculation? We don't know. Let's go back to this one here. The alignment of the planets in the sky determines the best time to make a decision. Hypothesis? Speculation. What do you think? Have a look. You'll see here that I'm very good at, I'm just very good all the time. But what I really meant to say was, I am a huge believer, since you guys are adults and you guys are learning this at home, I'm a huge believer of giving you guys questions and the answers. And I promise you I'll do my best, not on tests, after the tests, yes. But the whole idea is I want you guys to make mistakes. Silly, eh? Why would your teacher want you to make mistakes? Because you have the answers. I'm going to give you the answers, but I want you guys to try these. And the trying them, make mistakes, you have the answer, see where you went wrong, you auto-correct, you correct yourself, and you move forward, right? So I promise you, as much as I possibly can, you guys will have all the answers to your questions there for your weekly questions. Why is physics considered a basic science? Okay, this is all from the PowerPoint slides. What role does mathematics play in physics? It's all about numbers. Physics is just another word for mathematics. Outline the steps of scientific method. Observation, hypothesis, predict, test prediction, draw a conclusion. Somewhere in along those lines. Okay? Distinguish between scientific fact and scientific law. Number 5, in life, it is seen as a weakness to change your mind. How is it viewed in the scientific community? You have to. You have to be able to change your mind. Okay? That's just, you can't argue with the numbers. What is the penalty for fraud in the scientific community? Very harsh. The same for fraud in the school. I think that if there's plagiarism, you might be given a warning and a 0, but I think a second or a third case, and that's it, man. That's out. Okay? So just be careful. I don't mind wrong answers if they're brought up and backed up by logical ideas. And if they make sense, I have no problem giving marks. All right? But plagiarism, we just can't have it. We're almost on the, that was part 1. Hopefully there, I skimmed over some of the PowerPoint slides there, but you guys can pause and stop and start this as you see fit and go back. And if you have any questions, just email me. We're on to vectors here. Welcome to the physics now. Okay? For a frame of reference, position relative to origin, usually described by coordinates. You guys have all heard of the XY graph, right? And but an XY graph is just two-dimensional. We use it there for on a piece of paper, right? To see if the number of vaccines as comparative to this is higher or lower, and we can do these kinds of things. But here, when you're talking about positions in space, there's actually an XYZ graph because 3 dimensions, right? And everything has to have an origin. Everything has to be somewhere. And we need to know this. The origin of the coordinate system is usually chosen as a matter of convenience. I think it was Descartes who created the XY graph and moved it onto the XYZ, 3-dimensional. These are some good definitions. Please make note of all the definitions there you've seen there today. Law, theory, because what else am I going to test you on? A couple of words here. We've got scalar and vector. Scalar is a distance, a speed, a force, or an acceleration without a direction. Example, I drove 90 kilometers on Highway 400 today to get to Georgian College. Okay, no direction. That is what we call a scalar value. Vector is this distance, a speed, a force, or an acceleration with a corresponding direction. I drove 90 kilometers north on Highway 400 today to get to Georgian College. Little different. One has some information. One is missing some information. Scalar, vector.
Let's get this party started. Go ahead and make an equal sign with those forearms and meet me in a plank. We're gonna roll.
Thank you.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Great movie, by the way. Cancel. There we go. Where are we here now? So, let's get on to it. Vectors can be added. So, look at this example here. Sam is walking east at 5 km an hour on a train that is traveling west at 15 kilometers an hour. What is the net velocity of Sam relative to the ground? Now, when we use that term or phrase or terminology there, relative to the ground, it's like somebody is standing beside the train. What does Sam look like to them? Now, I see here Sam is walking 5 kilometers an hour. Yes, that's a pretty fast walk. Sam is walking 5 kilometers an hour east on the train, but the train is going west at 15 kilometers an hour. Solution. You set one vector as positive and one as negative. Why? Because they're going in the opposite direction. So you see Sam is traveling this way. If you can imagine a train here, Sam is walking backwards to the caboose on the train, but the train is going forward this direction. So here we have -5 kilometers an hour west plus 15 kilometers an hour west. And you see here, he was actually traveling 5 kilometers east an hour. Well, if we can change that to -5 kilometers an hour west. So here you have -5 plus 15. So according to somebody on the ground, we're looking at the train and Sam, it looks like Sam is only moving 10 kilometers an hour, while in fact the whole train is moving 15 kilometers an hour because he's walking back. So this is what we've got right here. All right. And I gave you guys a whole bunch of these practice questions. Try them out. See, you guys have the answers. Try them all out. And if there's any issues, let me know. Okay. When we get into trig, and that's what we're going to get into in the next couple of minutes here. You know, like Sally walked 7 meters north and then turned. And this is where we're going to get into. Your most important thing for this, actually for all of what's happening there for this course, I will try my best to provide some type of a diagram. But if there isn't a diagram, draw one. Just over in the margin, doesn't have to be big, doesn't have to be, but just in your own there, you've got to have the right schematics of what's happening here. Because sometimes it can be a little confusing. Okay? But we're going to be mainly focused on these right triangles. And you see a triangle, 3 sides, 3 angles. But the special thing there about a right triangle is that it has a 90-degree angle to it. All right? And either of these two can be any number, but if you add them up, they have to be 90. Okay? That's the special quality about this triangle. And with it, there comes special things that we can use to find answers. And you see here, this one here is always 90. If you don't see this little square here, you can't assume that it's 90. If it's there, that's 90. So therefore, this one here is 30. Then therefore this one here has to be 60, right? Because those two add up to 90. Welcome to SOHCAHTOA. SOHCAHTOA. Trigonometric functions. We've got sine, cosine, and tangent. And you'll see there SIN, that's the short form. COS, the short form, and TAN, short form. Sine, cosine, tangent. What are these? I'm just going to... Let's have a look here, see if this works. Sine is opposite over adjacent. Now, what we're going to be doing here is we need to find, sometimes here we may need to find this angle. And this is what this is theta. And we use this kind of like x in algebra, right? X plus 2 is equal to 4. We'll solve for x. This is the same thing here. Okay, so we use this to denote that you're looking for an angle. All right, so you see there that this one here is 90. So this one here and this one here, you add these two up, they have to be 90. But sine theta is equal to opposite over hypotenuse. Hypotenuse should ring a bell. When you're talking about a right angle triangle, the side that is opposite the 90 is always your hypotenuse. Now, this angle here, the opposite side will be opposite. This side here, closest to it, but not the hypotenuse, is called your adjacent. We'll get there. But have a look here. There's your opposite. There's your hypotenuse. So, this is the formula here that you won't have to, and remember, you don't have to memorize any of these. You're going to have them on a formula page that you're going to start there today, and it's going to continue on week 1, week 2, week 3, and then you've got all your formulas there on one page ready to go for your week 4 test. That will continue. You can throw those away after, and then week 4, 5, 6, you can start making a new formula page. And I'll help you guys out on that as well. So sine is equal to opposite over hypotenuse. Cosine is another relationship. And this one here is now adjacent over hypotenuse. Probably not making any sense right now, and that's okay. We'll get there. Adjacent over hypotenuse. These are just what we call ratios. Okay, and we'll show you how to use them there in a second. And tangent, this is opposite over adjacent. All right, so this is why we say SOHCAHTOA. I don't know, it was the same for me when I was a kid. S-O-H, so, C-A-H, ka, T-O-A, SOHCAHTOA. All right? This is for people there who are doing an in-class test and don't have formula sheets. Y'all will. So, what does all of this mean? So, I'm just going to back it out of here just to... Now, what we've got here now, as I said there before, they're just ratios. So, here's my angle. Now, remember, your angle could be up here. Right? And then, but let's just have a look here. My angle theta is here. So I want to find this angle. Well, you use either of these formulas, depending upon the information you have. And here in this triangle, we've got the hypotenuse of 10. This side over here is 8. This side over here is 6. And the only other information we have is the 90. So we don't know what this angle is, and we don't know what this angle is. But using any of these guys here will help you do it. So this angle here, we're trying to find sine theta, opposite over hypotenuse, 8 over 10, which is 4 over 5, which is 0.8. 0.8. Cos theta, adjacent over hypotenuse, which is 6 over 10, which is 0.6. Haven't shown you guys how to use these yet. We're just introducing what the ratios mean. Tan theta, opposite over adjacent, which is 8 over 6, which is 1.33333. All right. Now, what do we do with these ratios? Again, it's all about trying to find the angle. So let's have a look here. See if I can, do I have any animation here? Did I take the animation off? Okay, let's have a look here. Yes. So here we want to find the angle. But wait a second. We're missing the hypotenuse. I have this side, I have this side, I have a right angle triangle, so therefore, how can I need this side here in order to get this. Pythagorean theorem. We can only use this when we have a right angle triangle. And this side here is A, this side here is B, or you could flip A and B. But this, the hypotenuse, is always, always, always C. So this formula here, A squared plus B squared is equal to C squared. So I just input the numbers there these are the only numbers I have. So 3 squared plus 4 squared is 9 plus 16. So add them up. C squared, 25. Now, what's opposite of squared? Square root. So you square root C squared, you square root 25, C is equal to 5. Try the mathematics, pause the video, try it out, okay? So now I know that C is equal to 5. So now I have all my sides. Let's rock and roll. If I want to use sine, sine is opposite over hypotenuse, which is 4 over 5. All right? So sine theta, that's how we write this. Sine of the angle that we're looking for is equal to 4 over 5, which is 0.8. There, on your scientific calculator, there should be a second function, an inverse sine. So play with it a bit. Every calculator is a little different. I don't want to get into how your specific calculator works, but if you're having issues, let me know and we'll get you sorted out. Because if you're going to make a mistake, make it on your own. Don't let the calculator make it for you. All right? So get to know your calculator. All right? Sine theta is equal to 0.8, 4 over 5. So you go inverse or second function sine 0.8. That should give you 53.1. So that angle right there is 53.1 degrees. And because this angle and this angle should be 90, if you add them together, you should be able to tell me this one too. Okay? So here we've got all of our sides, so we can actually use sine, cosine, and tangent to solve these, because I have all my sides. You have all your sides, man. You're rocking. Okay? And you'll see there that with cos theta is equal to adjacent over hypotenuse, you'll see there that you get the same, so the math works. It doesn't matter if you use sine, cosine, or tangent to solve these things to get angles. It all works. But sometimes I won't give you one of the sides. So now you're just left with opposite over hypotenuse, so therefore you have to use sine. maybe I won't give you the hypotenuse, and you'll have to use, because you have all these different ratios, okay? You'll see what I mean once you try some of the questions, all right? You guys can try these, okay? Find the sine, cosine, and tangent of angle A. So here's my angle that I want. I've got all my sides. It's a right angle triangle, so I could use sine, cosine, or theta, or tangent, sorry. And if you do the math there, you'll see there that you get the same answer for each one. Try these out. A surveyor standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? Okay? And here we are. So this could be given to you, or this may not be given to you, a diagram. You would have to draw it. You know what I mean? Even if I'm going to do a question like this, I draw a little diagram for myself. So you have 50 feet along the bottom. The question, how tall is the tree? And the angle of elevation is 71.5. Now you look at this. I've got a right angle triangle, but I've only got 2 bits of information. I don't have my hypotenuse. I don't have, this is my side A, this is my side B. I've only got 2 bits of information. Well, if used correctly, that's all you need. So I have the angle here. I have the adjacent side to the angle. I am looking for the hypotenuse. Or sorry, scratch that. I have my adjacent side. I have the angle of inclination here that I'm looking for. I'm looking for the opposite side. So I have the adjacent, looking for the opposite. So any formula out of sine, cosine, and tangent that involves a hypotenuse, can't use it here because I don't have a hypotenuse. I only have the angle in the adjacent side, looking for the opposite side. If you go back and check out the formulas, the only formula there that will work here is tan. And so tan theta is equal to, yeah, that should be adjacent right there. Opposite over adjacent. I'll fix that up in I'll update the PowerPoint there. But this is opposite over adjacent. Okay, so tan. And now here, we actually have the angle. You remember there before, we didn't have the angle, right? We were looking for the angle. Here I had all the sides, but then here, I've given you the angle because I'm looking for something else. So tan of 71.5 is equal to opposite over adjacent, okay? And you just do the math here. Now and you fill in what you know. Tan of 71.5 is equal to opposite, that's what we're looking for, over adjacent. Adjacent is 50, so I input 50 there. And opposite divided by the adjacent here. You need to get rid of this guy on the bottom. What's opposite of divide? So you multiply it to this side, multiply it to this side, and it'll cancel. If that doesn't make any sense there, I'll make up an exercise sheet on some basic algebra. Okay? But in order to solve for this one, because that's what we're looking for, the height, I need to isolate it. Well, here you've got to divide by 50. Well, how do you get rid of that divide by 50? Multiply by 50 to both sides. So that 50 over 50, here we'll go to 1, that's gone. You brought your 50 over here, input it into the calculator, you get 149.4 feet. Okay, so that's what we're looking at there. All right, that's a good little question. Let's have a look at this one here. A person is 200 yards from a river. Rather than walk directly to the river, so I guess here's the river. Rather than walk directly to the river, the person walks along a straight path to the river's edge at a 60-degree angle. So they're 200 yards from the river, and they're walking towards the river at an angle of 60 degrees. Draw it. There's your right angle triangle. How far must the person walk to reach the river's edge? So just looking at this, not so easy to figure out which side I'm looking for. Meaning you got to draw this. Okay? So now by drawing it, we realize that I want to find the hypotenuse. Okay? So what we have here now is what are we going to use? Sine, cosine, tangent? Well, tangent, there's no, let's just go back here. Right here. So we're looking at adjacent and hypotenuse because that's all the information there I've given you. Okay? We've got the angle and the adjacent side. And I'm looking for the hypotenuse. What is the only formula that will give you this that will allow you to incorporate this information? Okay? And that's cos. Cos theta is equal to adjacent over hypotenuse. So, I give you the angle, input the angle. Alright? We're looking for this guy here. Got to bring it up and then bring this guy down. That's what we did. That's a two-parter. Because our unknown is on the bottom, you just can't move this 200 over here. No. It's 200 divided by x. You got to get rid of that divide. So bring that, multiply by x, multiply by x. That'll cancel on this side, and the x will pop up over here. So now I have x cos of 60. Get rid of that cos of 60, bring it over here. You've now isolated your unknown. X is equal to 200 divided by cos of 60, which is 400 yards. Try this out. This is probably the first time you're seeing this stuff. So if I'm blowing your mind, it's all good. Learning is learning. It's not easy sometimes. Vectors can be added. We've already showed you that there with Sam on the train. Okay? You travel north along a road for 40 kilometers. Traveling north along a road for 40 kilometers. 40 north. Draw it. Then make a right turn at 90 degrees and travel for 30k. So turn right. You're going east at 30. Okay, direction of magnitude. How far are you from your original starting point and in what direction? Aha. So we have a right angle triangle. We can use, here we are. Okay, so you can use your Pythagorean theorem to solve this guy. Okay, which right here, C is 50. All right. But then, because this is vector, not scalar, I need direction and magnitude. Magnitude just means strength. So in this case here, it's 50. But I need an angle as well. But I've got all three sides, so you can pick and choose. You can use sine, cosine, or tangent because you have all three sides. Easy peasy. Here I just use sine there as it's the first one on the list, right? So opposite 30 over hypotenuse 50. So sine theta is equal to 30 divided by 50, and then the angle is equal to inverse sine. Okay, right there. Use inverse sine now, and you should get that angle. If you don't get frustrated. All right, try it again. Oh, and by the way, if I'm not perfect by any means, and I've gone through this, and we've already seen one mistake, which I'll clarify there when I re-upload the PowerPoint. But I don't want you. One of my students there, it happens all the time, where a student will try a question and then check the back of the book. Oh, it happens all the time with these textbooks that you buy. You pay for, $230, $400 even, and there's a wrong answer in the back. Do a question 2 or 3 times. If you're still getting the wrong answer, don't do it anymore. Don't waste your time. Email me. Say, Ian, number 43 on page 267. I'm not getting the right answer here. Here's my answer. Here's their answer. Can you investigate? I'll go and do it. Waste my time. I'm getting paid to do this. All right? So don't waste your time and do a question. One student spent a whole night trying to get this question, and it was a wrong answer in the back of the textbook. You know what I mean? So don't waste your time. Waste mine. All right. So we've got this here. Ultimately your answer, you're 50 kilometers northeast of your starting point, running at an angle of 37.86 degrees. That's all we're looking for there. Let's have a look here. All of the triangles up until this point have been dealing with right angles. There is one, though, that we can't use sine, cosine, and tangent for, because those guys are only for right angles. You have a look at this example here. It's not bad. It's not crazy. Let your calculator be the donkey, but it's just a different example because you will see it on the quiz and test. It involves a new little formula. You are flying north at 250 kilometers per hour. So you draw north, arrow, 250 kilometers north. You then make a right-hand turn at an angle of 60 degrees. So you're actually kind of coming back. All right? And you reduce your velocity to 200 kilometers an hour. What is your net velocity? So we're going across. This is what we're looking for. We don't have a 90-degree angle, so we can't use sine, cosine, or tangent. But we do have side angle side. Maybe that will ring a bell. Remember side, 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 side angle, side, angle, angle, angle. Remember those guys there. Okay? So there's a formula that you'll have to use. It's not bad. Again, let your calculator be the donkey. In this particular case where I'm asking you to find a side of a triangle, but you don't have a right angle, you want to use this one right here. Okay? This is called the Cos law. All right? And side A that you're looking for, so that's this one here, and you see the angle is opposite the side you're looking for. Okay? So side A squared is equal to B squared plus C squared, the other two sides, minus 2 times B times C, and then cos of the angle. Crazy, eh? Don't worry, just plug in and it'll spit out a number here. And my advice, again with these scientific calculators, do not punch this whole banana into the calculator. Don't go bracket 250 bracket squared plus bracket 200 bracket squared, because the calculator will pooch out a bad answer. Okay? Take it in steps. So here's your formula that you're getting. Okay? Plug in what you know. Side B, 250. Side C, 200. Minus 2 times 250 times 200 cos of 60, which is the angle. I haven't done any mathematics yet. I've just plugged. Not playing yet. Do it in steps. What's 250 squared? Calculator will tell you. Input it. What's 200 squared? Let the calculator do it. Minus. You can do these guys right here. Gives you a mil, or is that 100,000? And cos of 60 is 0.5. All right, order of operations. Okay, I'm going to do these guys first. You can add these guys, subtract, and you get this number here. So it's 229.1 kilometers an hour. That's where you're at. Okay, so Now that you have this side, and this side, all right, now you find the angle C in order to find the direction of the net velocity. Again, we're going to use the Coase law. So, in this case here, now, we've got all these guys here, but I'm going to be looking for the angle. So you're going to use the same formula, but before we were looking for the side, now we're looking for this angle. So you plug in what you know. So we want to find this angle here, because that's pointing us in the direction from our original starting point. So the opposite side, 200. That's what this guy is here, is equal to A and B squared. We've got in here. All right. And you just follow it the same way. Just be careful, though. This tends to screw people up. People tend to make mistakes there when they're just looking for the angle. Get all your numbers out of the way. Get them moving over here. So it's positive 52,500. Get it out of here. It'll be negative on this side. And here I've got positive 62,500. Get it out of here. It'll be negative. And you see I've removed those right here. And I have negative 75,000 on this side. It's okay. All right. Just so happens there that you've got a negative on this side. And what happens if you have a negative number on one side and a negative number on the other? They both cancel each other out. So therefore now it's positive, positive. Okay. Now you do your inverse cos and you get your angle. So right here, you're traveling at 229.1. All right. At an angle of 49.1. That's what we got there. Sorry if it's not, it's kind of better when you do it on the whiteboard, you know, in front and you can see step by step. But try these out. The biggest thing is going to be getting to know your calculator. All right. And how it works. Scientific, and honestly, if you're in my chemistry course, or if you're in any chemistry there, 1009 there this semester, you're going to need the scientific calculator anyway. So it's a good buy. You'll need it for this course and the chemistry as well. What do we got here? Vectors in the real world. Let's have a look.
Hey, Stewie. It's on. No. This episode is brought to you by the Air Force Collaboratory. GPS is important to everything in our lives. That is why we are totally replacing it. Wait, what? In a couple days, the Air Force is launching another new GPS satellite into space. GPS-2F5 is the 5th upgraded satellite in a long-term plan to make GPS faster, more accurate, and more efficient, which is awesome, not just because I can't find anything more than a mile from my home without it, but also because it's used in everything from ATMs to dog collars to farming equipment. The first generation of the Global Positioning System was created by the Air Force in 1973 for doing complex things like finding lost soldiers and instantly figuring out the math required to launch a missile from a mobile platform. GPS, as you and I know it, started in 1989 with the launch of the first GPS-2 satellite. The new network was open completely to the public in the year 2000. The GPS network is made up of 24 operational satellites and some extras for backup. 4 satellites always have a line of visibility to your receiver at any time of day. Your receiver gets information on the location of at least 3 of the satellites around you and the distance between you and those satellites. And using those measurements lets your receiver pinpoint where you are. It's called trilateration. Now, to do this, all the GPS satellites and receivers don't just have to know where they are, they have to know exactly what time it is when they're sending their positions. Say it's exactly noon and you check your GPS. If one of those satellites think that it's 12:01, it's going to mess up your position. It might think you're moving. That's why every satellite's got an atomic clock in it that is accurate to a billionth of a second. And every receiver uses a quartz clock that constantly resets itself to match its time to the last one it got from the satellites. And that's also why GPS isn't just used in positioning anymore. It's also used in timekeeping situations where everything needs to be synchronized perfectly. Stock market trades use the atomic clocks in the GPS network because just a fraction of a second could change the ownership of billions of dollars. It's also used in ATMs. With more and more of our lives becoming dependent on GPS, it's not surprising that a massive upgrade is underway. Type 2F satellites like the one being launched in a few days are considered interim upgrades that have a 12-year lifespan, improved clocks, and a new type of signal for everyday use. And by 2020, we'll be using Type 3 satellites. They're going to have newer clocks that are accurate to a fraction of a billionth of a second. Super important for military and financial uses. They will also have increased signal strength and accuracy. While GPS is accurate to about 20 feet, the new Type 3 network will be accurate to an arm's length. I don't know if that's like a tall guy's arm, or my arm, or like a baby arm, or what, but I feel like my eyes might be able to take it from there regardless. If you're interested in the GPS network, our sponsor...
Okay, and you'll see here that this video was made a long time ago. So things have changed. And we've just got more and more accurate. The homework there, I'll punch all that up. I'll have a look here. What do you guys got here? Here's some trig questions that I made. Okay, SOHCAHTOA practice. Alright. And have some fun with these. They're just getting you to do exactly, they're just play with the trig functions, the sine, cosine, there might even be a Pythagorean theorem in there. And I made answer sheets. Not only do you have the answers, I've given you guys kind of a step-by-step. And hopefully you guys can read my chicken scratch. Alright? What else we got? Vectors. These are good. Have a look at these ones here. And you've got all the answers as well. So, play with these. Do you need to try them all? No. But pick and choose which ones, just get familiar with these. And remember there, as far as quizzes and tests go, there's really no immediate rush. Everything is open book. And... so start getting organized, getting your formula sheet, getting everything ready to go, and you guys will be just fine. Other than that, I got nothing. So I hope you guys are great. If you have any questions, just email me. I'm always around. I check my emails 4 or 5 times a day anyway. So let me know if there's any issues. And other than that, take it easy. Next week is the study of motion. Thanks, guys. Have a great day. We'll talk to you soon.